Hi everyone, my name is Tiger. I'm here to explain the solution of problem set 1 to you. So before we start, I have two things to talk about. So first, I want to say that I actually checked the average high school GPA of the first year student admitted at Brandeis. They their high school GPA, average high school GPA here is 3.9, and the average SAT score is like 1450. It's very high. So I trust you that you guys are juniors and seniors. So I trust you that you guys are smart and you can do everything on your computer. I highly encourage you stop like handwriting your solutions, because you know everything except you are starting your own business and you're the CEO, you're the boss, you can just sign documents. Except for this, everything you will do it on computer and you need to present it in a professional way. So I think please submit your homework, problem set, everything uh, in one PDF. It's very you can do it. It's very important. So you can combine screenshots of the HTML document, or you can just export the Rmarkdown file as a PDF. So I will show you how to do this. So don't worry. I will send you the Rmarkdown file with PDF that I use. So actually, I did this problem set just like you guys. So, and I write everything in it. You don't have to copy the problem set, like the problem description, but you can write everything, like the latex answers, and you can design this. So let's talk about this. Okay, so here I have the solution. The first problem asks you about how to find use central limit theorem. So I actually copied the statement of the central limit theorem. It's like, given a random sample of size n drawn from any population with a finite mean and finite variance. So you know the population. Like actually, you don't know the actual population mean in the most of the time, but actually, so this tells you you don't have to know about the population distribution, right? You just use the sampling distribution of the sample mean will approach a normal distribution as n becomes large. So you don't have to care about the shape of the original population distribution. The important thing is that x1 to xn are IID, right? Independent and identically distributed random variables. So you use this formula, and your assumption is that this Zn will approach to normal distribution, standard normal distribution, with mean 0 and standard deviation of 1, as n approaches to infinity. So here is an example. You can like find the probability of the sample mean y, sample being between 101 and 103. So you know the mean of population distribution is mu y is 100, and you know, so basically you know the population mean and you know the standard deviation of the distribution, and you use the formula here, and you find your z-score, and you find the z table and the probability corresponding to z equals to 3.66 is approximately here. So use this 3.66 minus 1.22. You got the probability in between those two population. Between those two, got your distribution. And then I like this one. You see, you can design this too. You can design this problem. So here, everything's in latex. You use two dollar signs and write something in between. So here you have this PR is probability, right? And use bar y. It's two bar y, and this leg is less than or equal to is LEQ and backslash. Yeah, and this is approximate. Right? You make a first level header. You can design this and everything. You wanna like Greek letter mu and just say mu, right? In the dollar sign between the dollar signs. Infinity, right? You can check this online. So basically, if you handwrite this, it takes you a lot of time, and you just lost it, right? You write a homework, and when the course ends, you lost the homework. And in this way, you can keep track of all your past works. And here, example, I use first level header. Here, I use the second level header for all the problems. Right? Problem 2, blah blah blah. And so I like this one. Random variable y has a mean of 3 and a variance of 4. So, and I can create math RM z. So design this z to be different, different from font. So here you click on this. Basically, it will show you the latex form of this. So mu z is you take the expectation of z, and what's z? Z is y minus 3 over 2, and you based on some the expectation rule, taking expectations. So it's a linear operator, right? So basically, this is y over 2 minus 3 over 2, and you can take this out and take expectation of y and expectation of minus 3. Expectation of a constant is itself is the constant, so you only care about the expectation of y. So what's the expectation of y? It's 3, right? So the expectation of z is 0. Expectation of z is 0. C. So basically, I want to say, like, it's easy. So yeah, you just write. So what's this random variable? And what's this random variable? And it's a linear operator. So basically, I only care about something with the random variable. Now y over 2 minus 3 over 2. So it's a linear operator. So variance of a constant, I don't care about this part. So I just the variance of a y with a constant a is square of a times the variance of y. So what's the variance of y? It's 4. So basically, the variance of z is 1. Final. So problem 3. So for each, you don't have to copy the problem, but I think I can check this in a clear way. So I copied everything. I understand this is hard at the first time. I remember that when I was a junior college student, it takes me so much time to learn latex, to learn Markdown, to organize my work, but eventually, you know, pays off hugely in the future. You know, a lot of master students, graduate students, they're still learning this. Still learning this. One day you will have to do everything on computer, everything. So I just don't get the point of handwriting. Why don't we start practicing now? Like, you know, start early. Start early. So you see here is a something wrong here, and I will check the markdown file. Something's wrong up here. I want square root of this. Square root 25. Right. So it should be solved. Right. So here you see your output. Something wrong in your output, and you export to PDF. And by the way, if you cannot export this as a PDF, usually you should install. Usually you should install mini, like tiny text. This should solve your problem. Just hit enter here. Try this. Okay, and a lot of time, it will worry you that you have to install a new package. Sometimes, yeah, system will tell you. Okay, so I will leave problem 3, problem 4 for you. I think problem 4 is very important, right? You tell the the null hypothesis is the mu1 and mu2. These two population mean null hypothesis is that they're not they're basically the same, right? Your alternative hypothesis is that they are not the same. So basically, you use statistics to tell if you want to reject. You have a very high probability that it's the alternative hypothesis, so you reject the null. If this t-score is very high, you reject the null. Right? You remember this formula is very important. And you take 2 samples. Yeah. I didn't copy the pictures here, so you need to check the pictures. For problem 4 and 5, you need to check the pictures. So basically here, you see is the estimated y is the one. Someone asks me about this. The estimated, or you can call it the predicted value of y, is the one with a hat. See here, it's like a small hat. It's like a small hat here, a y with a hat. So the predicted value of y you can get from a regression line, right? Slope is I think the slope here is 5,000. Okay, you can check. Slope here is 5,000. So sorry, 50,000, not 5,000. Another mistake, so you need again. Okay. So you plug in 3, you get the predicted value of your y, which comes from your regression line. And you can get the residual. It's your actual y minus your predicted value of y. It's your residual for every 3-bedroom house, right? So 3-bedroom house. Okay, so let's take a look at the empirical questions. So these are the ones you have to do it. You have to do with the Rmarkdown file. Again, you don't have to copy this, but usually I will. First level header, second level. You don't have to copy the problem descriptions, but when I like review the problem sets for my test, I usually want everything in one PDF, so it's extremely organized. You can just check these problems. And these are the code. These are output, right? These are the output on code. And these are the problem descriptions. So basically, I use summary econ. The dataset name is econ. You can check the number of observations. Read. Always put everything together. Read your dataset. Read your dataset. And summarize summary statistics. Every variable's mean, median, minimum value, maximum value, and everything. So you can also tag writing here, type something here. See here, use R code. So this block, this shaded block, is your R coding block. Actually, I think you can also use Python here. I don't know. Let me try it. So I used the 5th level header for each part B, part C, part D, and this white area you can just type like normal texting message. And you use this shaded block. You can here add a coding block. See, you have another coding block for R. These R code are in the shaded area. See, R code. If your code can run, yeah, it will successfully export this PDF for you. But you have to make sure you can run your code. T-test. Check the correlation. There's one issue with the correlation. So some of you explain the R square as the same effect of correlation. This is true. This is somewhat true when you have only one explanatory variable, so only one x. If you have 2x, the R square is not the correlation between explanatory variables and y. Right? If you have a single variable, somewhat we can accept that answer, but R square is a different thing. It's the variance explained by your explanatory variables in your model. Right here, see, you can check this. And Stargazer, I like this. I really like this Stargazer. You can install it and use library Stargazer to use this. When you write a regression give it a name. Reg 1, you have a regression and you show it you're using Stargazer. The output of this table is very neat. Just use Stargazer. Very good. And you can like text your regression line here, right? You can type your answer here, just below your coding block. Here you see, just below your coding block. So if you wanna do this more better way, you can also use latex. Hit on need to PDF. And when you finish, you can submit this. You have all your answers, you have everything here. You don't have to take a screenshot. And you can also keep this, right? You can also keep this for your review. You don't have to lose this. Even after this course, you can still keep this. Anytime you want to check it, just use this. Okay, that's pretty much it.